Today we are going to see an interesting geometry problem. So the first question is, what is the problem? Let's consider a rectangle, a simple rectangle. A rectangle of one side being 10 units and another side is being 5 units. Okay. Now let's consider a semicircle inside it. The radius of the circle will be 5 units. This is a semicircle. I mean, the half of the circle is inside the rectangle. Another half isn't any problem to us, so half of the circle is inside the rectangle. So far the problem is, there is a rectangle of 10 units and 5 units. Okay, and there's a semicircle inside the rectangle of radius 5. So the radius of the circle is 5. Now if we connect these 2 points, we'll get a diagonal of this rectangle. Our concern is to find out this area. Our concern is to find out this. So how to find out this area? There can be different approaches to solve this problem. One can be a geometric approach, a classic geometric approach. Another can be deriving a general solution, or we may use calculus too. So this video will be of 3 parts. So in first part we'll just see how to solve this in classic geometric approach. Okay. So far the problem is, there is a rectangle. There is a rectangle of one side being 10 units and another side is being 5 units. And there is a semicircle. There is a semicircle inside this rectangle of radius 5. We are connecting these 2 points of the rectangle to get this diagonal. Now our problem is to find out this area, which is colored orange here. So to find our desired area in classic geometric approach, but first you can try by yourself. Let's give it a trial. So if you find it difficult, so let's solve it. Now to get this area, what can we do? We can just first simply take the area of this triangle. Take the area of this triangle, and which isn't any difficult. Then from this, we can subtract this region. And also we have to subtract this region too. So to find out this area, to find out our desired area, we have to take the area of this triangle, and then we have to subtract this green region. We have to subtract this green region, also this white region, also this white region. Okay, so first things first, so let's find out the area of this triangle first, and which isn't any difficult, because we know the simple formula of finding the area of any triangle. It is just simply half into the base, and the base in this case is just simply 10 and the height is 5. So the area of the triangle will be just simply 25. After getting the area of this triangle, what we have to do? We have to find out this area and this area. We have to subtract these 2 regions from the area of the triangle. So let's find out what is the area of this white region. So to find out the area of the white region, what can we do? So let's consider a square. So from this square, if we subtract this circular sector, then we'll get this desired area that we're going to find, that we want to find. So the area of this square isn't difficult. So what we have to do, let's be clear, we have to subtract the area of this circular sector from the square to get this region. So how we do it is simple. So the area of the square is a bit simple to find out. The area of this square is just simply 5 square, I mean 25, and we have to subtract this circular sector from the area of the square. Okay, and what is this part. What is this circular sector is? Now, I hope everybody knows what is the area of a circle. We know the area of a circle is just simply pi r square. If we want to find a portion of this circle, if we want to find a portion of this circle, in this case, this portion is just of 90 degrees. So we can see that this portion is just 1/4 of the total circle. Then we can say area of this portion is just simply, because we know the total angle will be 360 degrees if we consider the angle in degrees. So the area of this portion will be just simply 90 over 360. 90 over 360 into pi r square. If we consider the unit of the angle in radian, then this total angle will be 2 pi radian, and this will be just simply pi by 2 radian. So if we consider the angle to be in radian, then this portion, then the area of this portion will be just simply pi over 2 over 2 pi into pi r square. We can use the angle in degrees or we can use the angle in radian, doesn't matter. So let's say we are taking the one which is in radian. What will be our desired area of this portion, this circular sector, which is 1/4 of the total circle? That will be just simply, here in this case, the radius of the circle is just simply 5. So 1/4 into pi into 5 squared is just simply 25. So we can say 25 pi over 4. You can see it doesn't even matter of what we consider the angle in degree or even radian, because you can just simply see it will be always just the 1/4 of the total circle. So remember, we wanted to subtract this circular sector from this square. Okay, so the area of the square is just simply 5 square. Now we have to subtract this circular sector, which we have derived that the area of the circular sector will be just simply 25 pi over 4. So now we have find out the area of this region, So we can say, so this is our area of this region. Okay. Now finally we have to find out the area of this green region, because what we have to finally find out is the area of this portion, and to find out that we have to subtract the area of these two regions from the area of this triangle. So we have already found out the area of this triangle and also this white region. So we have to subtract this white region from the area of the triangle and also this green region. So now we have to find out this green region. How can we know the area of this portion? If we connect these two, then this will be a circular sector. And already we know how can we derive the area of any circular sector from a circle by knowing how much is this distance. So now we have to find out this angle. Now we have to find out obviously this angle. So to find out this angle, let's say this angle to be theta. Okay, so this will be also theta because these both sides will be equal, because they both are the radius of the same circle. So they both are just 5. As this both side is same, so this both angles should be also same. So what will be this angle? As we know that in case of a triangle, the sum of the three angle must be equal to pi radian, or in degrees just simply 180 degree. Okay, so let's stick to radian. So as we know that the sum of the three angle of this triangle will be just pi, and this 2 is just theta, and this is also theta. So we can say that this angle will be just simply pi minus 2 theta. This angle will be pi minus 2 theta. Okay. So now you may ask, how can we know that this theta angle? Okay, knowing this theta angle won't be very much difficult, because we already know what is this side. This is 5 and this total is 10. If you want to know theta, we can see from here that tan theta is equal to, we can say tan theta is equals to just simply 5 by 10. I mean tan theta equals to half, or theta equals to tan inverse. Theta equals to tan inverse half. Now what is tan inverse half? So we can see tan inverse 0.5, I mean tan inverse half is just simply 0.46 radians. As we are using radian in all other cases, in this case we have to use radian too. So make sure about that. As we know this theta to be just simply 0.46 radian. Just note down. So this angle will be just pi minus 2 thetas. 3.14 minus 2 into 0.46. 2.214. Now we can easily find out this area. But we only need this portion. So after finding this circular sector, we have to subtract this triangle from it. Then we'll get this region, this green region. So let's first find out this circular sector. So this circular sector will be, in case of radian, the total angle is 2 pi. 2 pi, I mean 6.28 radian, and this angle is just 2.2143 radian. So into pi r square, which is in this case just simply 25 pi. So if we calculate that, 27.6, this will be the area of this circular sector. Now we have to subtract this triangle from the circular sector to get this green region. So as we see this triangle, these two sides is same. So to find out the area, and how to find out this area? So if we consider a triangle of being ABC, that means this angle is A and this angle is B and this angle is C. If we represent those angles by capital letter and on the opposite side of each angle with a small letter, with lowercase letters. So this side will be A and this side will be B and this side will be just simply C. So we already know the area of any triangle is just simply half into base into height. Half into base into height. So in this case we can say that the base is just simply BC or A. BC or A, because BC equals to A. Now what is the height? As this angle is B, we can say that sine B is equal to just this side by this side. Sorry, I have to mark this. Let's see, this is D. So we can say sine B is equals to AD over AV. So we already know AB is just side C. This side we are representing with this lowercase c. So it is just simply AD over C. Okay. So from this we can say that AD is equals to just simply C sine B. So this height will be just simply C sine B, because this is the height. So from this we can say the area of the triangle is just simply, so what can we understand from this formula? We can see that the area of any triangle is just simply half into any of the two sides, in this case A and C. Any of the two sides into the angle between the two sides. So we can also write area of this triangle as half into AB sine C. Okay, because when we are taking this side and this side. The angle between these two sides will be this angle, the angle C. And we can also write half into B into C sine A. Now we can say what is the area of this isosceles triangle. Okay, as we see, this two side is just 5 and 5, and the angle between them is just simply pi minus 2 theta. What we are actually trying to do, we're trying to get this green region. We are trying to get the area of this green region. And to get the area of this green region, what we have to do, first we have to take the area of this circular sector, and from that we have to subtract the area of this triangle. Okay, so we have already calculated the area of the circular sector. Okay, and which we have derived is just simply 27.68 units. Okay, so this is just simply 27.68 unit. Okay, and now we can say what will be the area of this triangle, and that is just simply half into 5 into 5 into sine of the angle between these two sides. Okay, we've already seen how we derive that formula. So this will be just simply half into 5 into 5, that is 25, and sine of the angle between these two sides, and that is just simply pi minus 2 theta. That is just simply pi minus 2 theta. Now let's concentrate it only to these portions. We already know the area of the circular sector and what will be the area of this triangle. Okay, so we can simplify this a bit. This will be just 25 over 2. Sine of pi minus 2 theta is just simply sine of 2 theta, because we all know that sine of pi minus 2 theta, which means pi minus something, some angle. So this means this coordinate, and we already know that in this coordinate sine will be positive, and as we see that pi, which is just simply the even multiple of pi by 2, so sine will remain sine, and also there won't be any negative sign. It will be just simply sine of 2 theta. So now what will be sine of 2 theta? Now as you already know what is theta, we can put that value here, but I don't think we don't have to use calculator in this case, because we can say that 25 by 2 sine of 2 theta is 2 sine theta. So 2 sine theta cos theta, this 2 cancels out, and now we can say that this is just simply 25 sine theta cos theta. Now concentrate to this triangle again. We already know that this side is 5 and this side is 10. This side is 10. So what will be this hypotenuse? According to Pythagorean theorem, this hypotenuse will be just simply root over 5 square plus 10 square. So root over 5 square plus 10 square. 5 square is just 25 and 10 square is just simply 100. So it will be just root over 125. We just can simply write, because we know 125 is 5 into 25. This will be just 5 root 5. So now we know the three sides of this triangle, and this is 5, this is 10, and this is 5 root 5. Now we can say that 25 sine theta cos theta, that for a right triangle the sine theta is just simply the opposite over hypotenuse. So in this case the opposite is 5 and the hypotenuse is 5 root 5. And what will be cos theta? And cos theta will be just equal, because theta is this angle, so this cos theta will be just equal to the adjacent over the hypotenuse. Adjacent is 10 is in this case, and hypotenuse is 5 root. So we can simplify sin theta to be 1 over root 5 and cos theta to be 2 over root 5. Now we can plug in these values here. So sin theta is equals to 1 over root 5 and cos theta is equals to just what? 2 over root 5. So we know root 5 into root 5 just 5. So 5, here it is 25, so it will be just simply 10. It will be just simply 10. So now we can find what is the area of this green region. So the area of this green region is just simply 27.68 minus 10, which is just simply 17.68. Now, so far what we have done, our main target was to detect this area, and to find out this area, we first take the area of this triangle. Take the area of this triangle, and that we have found just simply 25. Then, if we want to find this orange area, we have to subtract. We have to subtract this green region and this white region from the area of that triangle. Okay, so the area of the triangle is just simply 25, and we have derived the area of this white region to be 5.37. Now we have derived the area of this green region too, and the area of the green region is just simply 17.68. So our final result will be just simply 25 minus 5.37 minus 17.68. Okay, so to find out this area, first we have derived the area of this triangle, and we chose just simply 25. And from that we have to subtract this region, which was just 5.37. And from that, finally we have to subtract this region, and that was the area we have calculated for this region was just simply 17.68. The final result will be just 1.95. So now we have solved it, and we have get our desired area. And so what we have found, the area of this region to be, that's it. Thanks everyone.